So let's get started. Up, up, down, down, left, right, BA, start. Assuming if you were playing any video games in the late 80s or 90s, your fingers were probably twitching as I said that. Of course, this is the great Konami cheat code, right? And in all kinds of games, it unlock all kinds of cool things: extra lives, extra treasure, power-ups, being able to move faster, defeat certain things. And that's the point of a cheat code, right? It's an unlock. It gives you an extra advantage against a system. And so why am I talking about that at a DevOps conference? Well, I started thinking about, what is it that brings us to these events, right? Now that we are in this unprecedented time and we can't meet in person, why are we all still here, right? And, I think part of it is the camaraderie and the networking and the maybe commiserating here and there. But I think also it's this idea of cheat codes comes to mind, that these are all these unlocks, the things that we're here to learn from each other that we can take back to our organization and give ourselves and our colleagues and our company really a leg up, right? And overcome the hurdles and the obstacles and the very difficult systems that are placed in front of us. So, the thesis of my talk, or kind of why I'm here, is to help make the case that I believe that Runbook Automation is the next great cheat code, for this community. It's the next great unlock that will bring us great benefit in all of our organization. So, in the next few minutes, I'm going to try to make that case, and hopefully I hit the mark. So, of course, got to start with the definition, right? What is Runbook Automation? Runbook Automation has a history of meaning different things, but I think what it means in its modern sense is the ability to give anyone in your organization self-service access to the expert operations capabilities that previously only your subject matter experts could perform, right? How do you give self-service to the things, to a broader audience for the things that previously, for whatever reason, you can only rely on your experts to perform? And, where does Runbook Automation really apply? Where does it shine, right? I think it's perfect alignment with operations, because it really shines in the two areas that I think are two types of activities that are really distinct in an operations organization, or operations work in general, not just people in operations, but anybody doing operations work, right? Number one, incident management, right? How do you diagnose and respond to and resolve problems in your systems? And then number two, service requests, right? All those interruptions, all those tickets, all those people that need you to do something, for them. These are the two areas where Runbook Automation really shines. But I want to focus in on making the case around incident management, because, I think incident management is really where the rubber meets the road in terms of an organization's operations capability. How good are we at detecting and responding and resolving problems? Really speaks to, how in control we are, as an organization when it comes to operations work. And, what do we want out of incident management? Well, I think this is mom and apple pie. Same thing we've been after for decades, is really the idea of, shorter incidents, right? How do we, solve problems faster but also fewer escalations? How do we solve those problems faster without having to escalate to more people? With, cutting down on disruption that we're pushing through the organization. Well, what gets in the way, is what's always gotten in the way, right? Which is complexity, right? And I want to be clear here, that, what I mean by complexity is not the idea that, things are complicated like the engine of a car, but things are complex like traffic in a city, right? And that complexity undermines our work and, makes it more difficult for us to have shorter incidents and fewer escalations. And this complexity is one of these things that, I like to follow, J. Paul Reed and John Allspaw, maybe also call them friends as well. But, they've really done a lot of work in these, bringing the safety sciences to our field. Great folks to follow on this. And, one of the things that kept trying to beat into my head was that stop thinking about our world as it's being deterministic. Stop thinking about our production systems as being deterministic. They truly are complex. And this disconnect in thinking about things as being deterministic versus more unpredictable as they are is really kind of causes a lot of these root conflicts that we have in kind of these DevOps conversations. And to show you what I mean, let's kind of lay it out here. If you think about development, we're kind of trained to think about things in a very deterministic way, right? Write some code, either it builds or it doesn't. Either it runs or it doesn't. It's a very binary outcome. We know the inputs, and we can predict the outputs. And if the outputs don't work, something must have been broken with the inputs, and we can go back and fix that. Well, we carry over that deterministic thinking to how we start thinking about our systems, right? From that kind of development first mindset, which is, oh, it's this collection of these deterministic things. It itself is deterministic. We can predict the behavior of it. We can version it, and we know what that version is, and we're guaranteeing that that's the version that's running. We think about these things in a very predictable and deterministic way. Versus if you talk to folks who spend all their time in operations, it's much more random, right? It's much more unreliable. It's much more unpredictable. And I don't know if you've seen one of these Death Star diagrams before, but Cornell made this tool for visualizing microservices. I think it's fantastic. Actually, this is a real SaaS, like a mid-size public SaaS service, and all the little gray around the outsides, that's the different microservices, right? The different endpoints, and all the blue is all the lines is the traffic that and the connections that happen between those different endpoints. In fact, it looks a lot like a wiring closet from a 1990s data center, right? And we realize that first of all, the sprawl of these things have kind of entered into the complex, but also there's all these things we can't change, all these things that change without us knowing, right? The API performance from external services, the hardware variation of the cloud platforms we're using, the network traffic, the usage pattern, what our users decide to do, library updates, data changes, these constant things that are moving around in the system that make it impossible to predict exactly what's going to happen. And then we're constantly tailoring these systems, right? They're never fit for purpose, never kind of one size fits all. We're constantly changing things to meet our business requirements or current, performance environment, or performance characteristics, or current usage patterns. And there's this constant kind of tailoring and change that happens. So, unlike we can predict our outcomes, we've got to fix the inputs. To this kind of a new, more stochastic view of things that is what the nature of operations, really is. And Richard Cook, Dr. Cook, one of the giants in the safety sciences field, who comes from outside of technology. He's an anesthesiologist. He studies, all kinds of one of the foremost researchers and accident investigators in the world, and all these other high consequence domains. He likes to call this on the left the system as imagined. What we hold in our head is, this deterministic view of what things are actually happening, versus the system as found, right? And that's our production systems, and really this much more random and unpredictable world that we're working in. And he likes to point out that, well, what do people do? What's the role of humans in these systems as found? Because as humans, we're both solving the problems and creating the problems. It's a very interesting dual existence. And next to point out that we're in this constant loop. There's monitoring, looking for signals, right? Whereas responding, which is really us trying to make sense of what are we actually seeing. There's adapting, right? Which is more tailoring. How do we evolve the system to try to get the right behavior that we're trying to achieve? And then learning, these constant feedback loops and understanding. And I think it's good to point out these three kind of main activities: responding, adapting, learning. These are things that automation alone can't do. The computers are actually quite bad at this, and humans are actually very, very good at this. Our ability to be surprised, our ability to coordinate, our ability to be inquisitive, our ability to redirect our gaze, based on what we're seeing from our colleagues, and just a simple thing like saying, "Wait a minute, I didn't expect you to do that. Can you tell me more about why you did that?" Right? That's something the computer is very bad at, but human beings in problem solving are very, very, very good at. And I think, where this goes to is the most important lesson that we've learned from other high consequence fields, right? Medical operating rooms, nuclear power plants, air traffic, right? Areas where they've spent, billions and billions of dollars and, thousands of person years trying to, reduce risk, trying to get humans out of the loop. What have they learned, right? They've all learned that the role of automation is best when it supports the human operator, right? Not when it's trying to replace the human operator. That when we're trying to replace the human operator, we have more problems. We have human beings in the end have to try to solve the problem fighting the automation, right? Versus the best designed automation that actually lowers risk and actually causes better outcomes across the board is when the automation is built to support the human operator. And Dr. Cook's kind of one of his, going back to what he was saying, one of his main points here is that we have to develop the trust in our operators. That's how we get better outcomes, right? And that too much of our design thinking goes into preventing people from doing things. How can we stop people from doing things to the system? How can we kind of lock people out and provide more automation to manage our systems? That causes more problems, right? And the path to safety is actually revealing the actual controls that are available, giving the operators better controls to both better understand the system, right? Kind of this idea of observability, and the better controls and be able to actually turn the knobs, pull the levers, and actually manage the complex system that we're faced with. And I sort of take this as, well, there's this abstraction layer that has to be resolved then, right? If it's too high, we get this black box, right? And there's a great paper that the Dr. Bainbridge from 1982 called "The Ironies of Automation" that talks about all the counterintuitive problems that come from and all the ways that our systems fail us when we build these overly automated black boxes. It's a great read. I put that up there with Dr. Cook has a paper called "How Complex Systems Fail." Both those papers, I think, are they're great reads. They're easy reads, and they're amazing because you think they're talking about modern complex computer systems, but really they're written several decades ago, and about different completely different fields. Highly recommended. So that abstraction, if it's too high, that's bad. If it's too low, I call this the SSH sudo a bag of scripts and say a prayer, right? That's bad as well, right? We all see how that chaos and that turns into problems as well. So we got to find this right abstraction layer. But what I've noticed is most companies end up punting on this whole problem altogether. What they do is their experts become the abstraction, right? What I mean by that is, well, we've got these few people and they know how to invoke the right things. They know how to target the automation at the right place. They know how to what steps to run things. They know what right options to put into it. They know how to look at the output and see if something's good or bad. And they become that abstraction layer. Now everybody in the organization has to plow through them to try to get anything done. And that's where we get the bottlenecks. We get the work synchronization points that slow us down. We get the burnout. A lot of the problems that we deal with today in operations comes from this. We're using the expert as the abstraction layer and trying to funnel everything through them. And of course, the first step to try to solve that problem people will do is, well, let's make more of those experts. So now we have several master craftsmen trying to, now we have coordination problems and, trying to work through that set of people, and actually can make things worse, right? So then we tend to restrict things more instead of make that circle that can do things even smaller and smaller. Now, this is where Runbook Automation comes in and is very handy, right? Is let's take that expertise, right? Not replacing the underlying scripts and tools and things we know work well, but taking that expertise of how to invoke and in what order and how to process the output and how to make safe inputs, and how do we take that knowledge and encapsulate it as code, encapsulate it as executable runbooks, and that helps create standardization so that team of experts can work faster, they can experiment better, they can learn quicker, but also they can now safely distribute that control to other parts of the organization, even people outside of what would traditionally be operations domains. So let me give you an example. Here's an incident management example. So we already met Alice, right? Alice is our senior individual contributor. She's the one that knows a lot about a lot of things. But so most incidents will come Alice's way, but Alice doesn't know everything, right? She has to decipher other parts of the system. So 3 options for Alice here. One is, she can decipher the wiki. What's this person trying to say? What do they mean? Who wrote this? When was this written? Is this even correct? Right? Or she can be on to, I know the network folks told me there's this Python script over here, but wait a minute, I have to edit some of these variables. Is this still the correct version of the script? Do I know, am I edit these things properly? What's the right, command line options I got to put in here? Seems a little bit dicey. So what ends up happening time and time again is option 3, which is escalate further, right? Let's call in, let's set the large bridge call. Let's call in the cavalry. Let's, bring in the, other folks who can try things that in the areas that they understand a little bit better. And all that's happening now is this incident is taking longer to resolve, and we're disrupting more and more of the organization. But with Runbook Automation, we can ahead of time take a lot of that expertise, take that, how do we diagnose these different parts of the system, put them into executable runbooks, and then let Alice be able to basically respond with the expertise of her fellow colleagues to, she can't do everything, but to be able to do a standard set of diagnostics, or maybe certain repair activities, restarts, clearing caches, rollbacks, maybe various procedures that we know will solve kind of known problems. So all the exploratory and and repair activity, how do we put that as much as possible into Alice's hands? She can respond faster. She's close enough to those underlying tools where she can see what's going on. And we see this kind of working in two ways. One is people use it for kind of an Iron person suit, right? Iron Man suit, right? Saying, how can we make Alice, stronger? There's all these expert actions. Other folks say, hey, let's also mix in some more robots, right? Let's go straight from our alert management to, firing off deeper diagnostics, maybe firing off some possible repair actions for known issues. But the idea is we're solving problems quicker and without having to escalate off to the rest of the organization. Can't solve everything that way, but we can solve a big chunk of things. And even better, Alice doesn't have to do it herself. She can now spread that load throughout the organization, let other people take some of that operational load. Alice, in her expertise, can focus on other work that's pressing for the organization. Works great for service requests as well, right? So, folks need a lot of things from Alice. She's the expert, and each one of those requests is a little bit of waiting that the person making the request has to suffer with, and interruption all being pushed onto Alice and disrupting her from her other work and kind of generally making her miserable with all those repetitive requests. Instead, use the Runbook automation to create self-service so other folks can safely is being the key word, safely help themselves. They get instant gratification and what they need to move on in their work, and Alice can focus on the things that she's trying to focus on. This is also great for enabling new organizational models, right? We talk a lot about you build it, you run it. Well, how do we do that in highly regulated or secure environments? We can't just give people access to these production systems, and there's all kinds of regulation and rules around it. But if we use Runbook automation, we're talking about executable code. We're talking about, hey, let's do a peer review and see this with security and with operations. What is this procedure? We're not giving people direct access to those production systems with the customer data in it. We're giving them access to the Runbook automation to do things. Compliance loves it. Security loves it. Things are more trackable. And we're giving people more freedom and more control while actually having a better security and compliance posture. And, what's the magnitude of impact here, right? It's one thing to go say, hey, this is going to be, you can see where it would remove headaches, make people's lives a little bit easier. But, often people think of technology as, well, we pay them to have headaches, right? So, how do we make the justification here to say, hey, this is worth investing in? What's possible, right? Again, your mileage may vary here. But if you think about it, it's not hard to think through, how do we solve incidents today, right? What if you can take out all of that escalation time, all of that extra waiting, all of that delay, all of those coordination issues? How much faster can you go? I've seen folks do it, 30, 40, 50, 60% faster. And I'm not talking about MTTR here, talking about looking at incidents where they have a good investment in Runbook automation versus where they didn't. What is all that waste that they can cut out of those processes? And, likewise with escalations. I've seen organizations where it's, how many of these are repetitive issues? How many things can be solved by pushing control closer to the problem? It's not unreasonable to say half or more of those problems can be solved without having to go through those escalations, right? And if you think about it from the service request side, what's 100%, right? Versus, having to fill out a ticket, waiting for someone to come do something, come back at you to make sure that, they knew what you're talking about, versus having the controls yourself to do it yourself. It's instant gratification, instant turnaround time versus having these long waits. So definitely worth, I think if you look in your own organization, you can find a lot of waste, a lot of value that's being left on the floor that you can gain back by using this design pattern. So that's my speed case for Runbook automation as the next great unlock or the next great cheat code for our community. Who thought I made the case? Raise your hands. Good, most of you out there. Maybe a few. If you didn't think that, if you didn't, let's talk. If you want to contact me directly, I'm Damon at pagerduty.com. That's new. And at Damon Edwards, I'm happy to talk. And thank you all for your time, and enjoy the rest of the event. And I hope to see you all next year in person. Thank you.